There we go.
Okay, welcome to this week's homework help night, guys. We've got a few problems to get through. I think we're sitting on 5 problems, so that were put in by Irma and I forget who else. So anyway, this is the first problem I want to work with. Now what I want to mention, and I've mentioned this before, your table might not have the same numbers as my table. So I've recreated the table, and what I'm going to do is kind of show you what you're looking for. So you're looking to kind of fill in the blanks, right? And there's a lot of blanks. Now the problem asks you to just calculate certain things. So total cost when producing 0 units. But the first approach to this is, I would say, the way I solved it, I filled out the whole table and then I went and plugged in the correct answer. So I'm going to show you how to start filling the table out and the strategy you use, and then let you guys figure out the rest and put in the answers. So first off, I'm not sure why that's here. Let's see, because I apparently can't write things correctly when I'm copying. So let's see, marginal cost, third one's 105, fixed cost, fourth one's 50. The variable costs for the second one are going to be 72. And apparently green doesn't like to erase today. Then we have 412 for the total cost. I'm missing something. Total cost is 412, and then we've got everything else. Okay, so first off, the way to start with this is, first off, your fixed costs, do your fixed costs ever change? And they don't. So you can fill in everything for 50. Even when you produce nothing, your fixed costs are still going to be 50. Okay, so that's where we start. So now we have our fixed costs are 50 at 0 units of production. By definition, variable costs can't exist when you're at 0 units of production, because variable costs are the costs associated with production. So at 0 units of production, variable costs are 0, your total costs are 50, and you've now filled out the whole top row and you filled out all of your fixed costs, right? So now what we want to know is, for the next problem, what is our variable cost? Now we've got a little bit of an option. Well, we don't really have much of an option. All the information we're given is what's before. We're given 50 units fixed cost, average variable costs are 50, and then we're told that next time around the variable costs are 72. We know that variable costs in the future aren't necessarily based on variable costs in the past, right? So we can't just say, okay, there's 72 here, so there's going to be, we don't know what that number is. The only thing that helps us is to know what average variable costs are. Average variable costs are variable costs divided by quantity. So we know that quantity right here is 1. So if this is 1, and the answer, let's draw it a little bigger here. If we know that average variable costs equal variable cost divided by quantity at that variable cost, and we know that the answer is 50 is our average variable cost, and we know our quantity is 1, we just need to solve for variable costs, and to solve for variable costs, we just multiply by 1, multiply times 1, and we find that variable costs equal 50. So we put that in here. Total costs are going to be equal to fixed costs plus variable costs. In this case, our fixed costs are 50, our variable costs are 50. We know this is 100. Okay? Now we can also calculate our marginal cost, because the marginal cost is going to be equal to the change in costs going from 2 points, the change in total cost divided by the change in quantity. And so right here we know that we're going from 50 to 100 and from 0 to 1. And so 100 minus 50 is 50. 1 minus 0 is 1, so 50 over 1 is 50. Okay? We can calculate average fixed costs. We just take total costs, or it's fixed costs, divided by quantity. And what we find is 50 divided by, 1 is going to be 50. And average total costs are going to be, average total costs are equal to total cost divided by quantity. So we end up with 100 divided by 1, 100. Now that we've got this, you should be able to calculate through and get your total costs. You should be able to get your marginal costs, and then calculate all of your averages from that. On the next problem, we know our marginal costs go up by 105. That tells us that going from 2 to 3 3 units cost 105 more, we can actually use that to impute what our variable costs would be, because the variable costs should be equal to, the change in variable cost should be equal to the marginal cost. And so what we find is this is going to be 72 plus 105, which is 177 for this problem. Then we do fixed in this, and we get 227. Then we can calculate our average fixed total variable costs. By the time we get down here, we're told what total costs are. Well, if we know total costs and we know fixed costs, we can calculate the remaining, which is variable costs. Okay? If we know this goes to this, then we know the marginal cost has to be the change from here to here. Just like the change from here to here has to be equal to this. Okay? So now you should have a methodology to actually solve the whole table. Once you solve the table, you look at the appropriate quantity and you put in the answers. Not too much rocket science going on there. And we will never use green again on this board. It's a workout. Okay. Sorry it's taking so long. I guess my camera guy could have paused, but I didn't tell him to because I'm stupid. Live and learn, right, Keith?
Meh.
Okay, so up next on the agenda is to go to problem 8. Blank the screen. I want you guys to see the answer. It's not going to let you anyway, because apparently the computer's being a prick to me today. If you guys don't know this, Delta computer, college computers aren't known for being efficient. So number 8 is a problem. It has Portia, is what it starts out at. And it gives you a graph. And the graph is, let me kind of draw it. We have quantity, we have price. And what they do is they give you a graph and they tell you, look, this is the marginal cost curve. And then they give you an average cost curve on the graph, but I don't want to draw it there. They give you an average cost curve on that graph to drag, and they give you an average variable cost curve. And the question asks you to figure out where to put the average cost and the average variable cost. And I'm going to show you that in a second here. It's not giving it to me. Okay, so what we know, the information it tells us, is that Portia knows the minimum average cost for a tracksuit is 7, and the minimum average variable cost is 5. So we know the average cost is 7. Let's get a brighter color. Average cost equals 7. We know that variable cost equals 5. So it'd be helpful just to take 5 out here, take 7, we'll put it out here. And the problem says move the graphs until those curves are at a minimum in the appropriate place in relation to the marginal cost curve. The only place to put the average variable cost where the minimum is 5 and it intersects the curve, because remember the important point is where we intersect this curve is going to have the average variable cost curve at 5 when it intersects the curve. And that's where that happens. For average cost curves at 7, same thing. What we're looking at is, because if we were using this problem, we want to calculate what the quantity is when the average variable costs are 5, what the quantity is when the average costs are at 7. And so this is our average variable cost curve. Then the problem goes on and it asks you, what would happen, so if Portia's average fixed cost was added to the left, what would it look like? And you're given some options. So instead of telling you the answer, let's look at what fixed costs would look like. So we know that fixed costs are a set amount. So let's say that the fixed costs equal 2 in this problem. So if we want to do average fixed costs for quantity of 1, and we know our fixed costs are 2, then we take 2 divided by 1 is 2. At 2, we do 2 divided by 2, which is 1. At 3, we do 2 divided by 3, which is 0.66666666. At 4 units of quantity, we do 2 divided by 4 is 5? I'm not sure. Let's see. 4, 2 divided by 4, 0.2. Yes, goes in 5 times. Okay. 2 divided by 5, or am I wrong? Let's see. Oh, well, it's easier if you do it right, okay? Half. Then we do 2 divided by 5, and we get 1 over 2.5.
0.4.
1/4, so we get a quarter. And my brain's not working, but anyway, we do 2 divided by 6, and we get a third. No, not a third.
I said 0.4 for 5.
0.45?
Yeah. No, 0.445. No, 40 for the number 5, sorry. Oh, 0.
I'm just too tired to get it, Keith. What is it, Keith?
0.4.
0.33, right? 2 divided by 7. Do we need to keep going? Anyway, if we graph these points, what's happening? The numbers are going down. And so we'd start at 2, and we go down over time if we added average fixed cost. Okay? So you guys can use that to interpret your answer. Okay. Up next is a problem on mainframe computers. Let me erase this stuff. And once again, this is a problem where the numbers are going to change. Depending on your problem. So not all of you will have the same numbers, which is nice because then you can't cheat off of my example. The computer randomly generates numbers for the problem within constraints. Okay, so now we have a whole bunch of different blanks that we want to fill in a table that is filled in. The reality is from what I taught you before, you should be able to do it. But what I'm going to show you is what do the equations look like for each of these, and then that can leave you to figure it out. There's a little bit of a trick. So for box A, we'd expect to see that total costs equals fixed cost plus variable costs. And what your unknown is your variable costs. For box B, same problem, total costs equals fixed costs plus variable costs. But now we need to find total costs. For box C, we need to know that marginal costs are equal to the change in total cost between two quantities divided by the change in those two quantities. In this case, I'll give you a little help. It's going to be 15,000 divided by 10,000, or minus 10,000, divided by 18 minus 0. Because what's happening is you don't want to look at the labor, you want to look at the quantity. We're going from 0 to 8 units. 18 units, sorry. And over this point, we're going from 10,000 to 15,000 in costs. So we want to subtract the 15,000 from 10,000, divide by the change here. What we're really calculating is the midpoint of the change between those 2 points on the graph on marginal cost curve. We calculate this out, we get 5,000 over 18, which in this particular problem is equal to 277.7. Okay. D and E are the same. F, we need to know that average cost equals total cost divided by quantity, and we're calculating for the average cost. For G, it's the same as F. And for H, we need to know that the average variable cost equals the variable cost divided by the quantity. I actually think the only hard part of this problem for most of you, for the people who asked, was they didn't get how to do C, D, and E. And what you weren't recognizing is that marginal cost changes are based on the average cost as you move from different quantities. A lot of the problems in the example that I give you in the PowerPoint and the examples from the videos that I did in class are definitive. We use 1 unit of quantity, 2 units of quantity, 3 units of quantity. If that's the case, then then the bottom part of your equation is going to be a difference of going from 3 to 4, which is 1, or a difference of 4 to 5, 1, right? And so we don't need to worry about that. So if you remember that marginal cost is the change between 2 points, and sometimes those quantity changes aren't given to us discretely as 1, 2, 3, 4, 5. We get jumps in quantity. Okay. Up next, moving right along, we've got question number 9. And this is a sorting exercise. I know all of you love sorting exercises. What I'm going to tell you, you're trying to sort between average variable cost, marginal cost, and average total cost. I'm not going to give you the answer of the equations because I've given that to you over the last few problems. So all the equations that you're given as examples, they just go in their appropriate place, right? So I'll give you this one. Average variable cost is equal to variable cost divided by quantity. Now all you're looking at is, what's the interpretation of this? And so the other options are literally using words to describe the equation. So I'll read one of them. So one of these is change in total cost divided by the change in output. Well, which of these math expressions is that? Then it should go in the same slot, right? All of these are just descriptive ways of defining these equations. So that's what I'm going to give you. That's the only hint I'll give you. Also because it's only 1, 2, 3, 7 going into that. There's only what is that? Maybe 60 permutations of how you could put this problem. What's 7 factorial?
I don't know.
Here. Inquiry minds want to know, people. Let's see where Google will do this for you. We'll solve everything. Will the computer work? We'll never know. You know your computer's good when the dummy page is locked up and won't go anywhere, right? Might be time for Delta to buy a new computer.
They got new ones in the library. They were installing
nice?
widescreens.
Oh, be still my heart. Okay. Let me blank this out for a second. So all we're doing in this problem, you're being asked to plot between 2 points. By the way, I think this is the last problem. But anyway, you're being asked to plot between points. I don't want to scroll down and give away the whole answer. But what we have is 2 graphs, and we have a table of information. The graphs have marginal product of labor on the vertical axis, quantity on the x-axis, on the second graph. And on the first graph, and I'll blank this out, but on the first graph we have quantity of bricks laid. So let me screw this over. So we have quantity of bricks laid divided by quantity of workers. Okay. And on the next graph, we have the marginal product of labor and the quantity of workers. And then as you can see here, we have a table. This is a little voided out by my stepbot, but quantity of workers, quantity of bricks. All you have to do is plot points. From the table. And if you can't do this, time to call the tutoring center. You've had to do this in the past in the class, so I'm not going to show you how to plot points on a graph. This is a basic skill you should know, but that's all you're doing is plotting points. So the question is, what do we do here? We calculate another row for our table of marginal product of labor. And how do we do that? Marginal product is just the change from one point to the other. So marginal product of labor is equal to change in quantity of bricks divided by change in number of workers. So for the first one, we go from 0 to 1 worker. So we get the bottom of our denominator is going to be 1 minus 0, or 0 minus 1 doesn't make a difference, and 10 minus 0. So for the first worker, their marginal product of labor is 10 over 1, which is equal to 10. We do the second worker. Well, if you notice, it's 0, 1, 2, 3, all the way down to 8 workers. It's discrete, right? We don't have to do any calculation. This is always going to be 1 in our problem. So what all we really need to do is see the change between 2 points. So from 0 to 10 is 10. From 10 to 18 is from 18 to 25, 25 to 30, 30 to 33, all the way down the line. Once you calculate your marginal products of labor, you're going to plot the points. It's not too bad. So anyway, that's the problems for the week that people ask for help on. If you need any more help or you'd like to see other problems done in the future, please ask. I don't mind doing this, but I just need to know what problems you actually have so that I'm just not standing up here randomly babbling about crap. So anyway, hope you guys have a good week. Hope the semester is going well and you're enjoying the weather. Talk to you later. Bye.